Okay, for Algebra 3, the notes are going to start for Unit 4, Analyzing and Transforming Functions. For this semester, we're skipping Unit 3 for right now, and we'll come back to it later on. So this is the beginning of Unit 4. This first section of Unit 4 is a lot of review of what you've had before, but there are some areas where I can help you understand things a little bit better and show you how how certain things are notated for Algebra 3 and above. The first thing we talked about is a relation. A relation is any set of ordered pairs. So you could see a set of ordered pairs like this as a point. And then we could have more than one, and then they're usually set like this. You can have ordered pairs in a table where maybe you have an x and a y. We could put the point 3,2. We could put the point 4,7. In Algebra 1 also you'd see mappings, and I'm avoiding them here. We don't tend to see mappings in any other course other than Algebra 1. You might also see ordered pairs listed on a graph. So if you had a graph, I could plot the point 3,2 and label it 3,2 and the point 4,7. A function is a specific relation. It has each element in the domain paired with each element in the range. The definition always sounds much more confusing than what it is. It just says the values for the domain must not be repeated. So if I had, like this relation here, 3 is different than 4, so that's fine. I could have an example of let's say I have a 3, 2, 4, 7, and then I add the point in a 3, -1. As soon as I repeated this 3, that is not a function. So that would be no good. I would have to get a different x value, which would be, let's make it 5. So this is an example of a function. The domain is typically the variable graphed along the x-axis and is referred to as the independent variable. So it's not always the x-axis. Sometimes it's the horizontal axis. I'm trying to think what other words you guys have used in the past. Let's keep that for now. The dependent variable is typically graphed along the y-axis or the vertical axis. And y depends upon x, and that's why it's called dependent. Also, so far all this is from Algebra 1. In Algebra 1 also you talked about function notation. So function notation, the value of a function, a number or expression. So f of x is read as f of x. So if I had f of x equals 3x, that means the function y is dependent upon what x is equal to. So you typically figure out values for x and solve them for y. It doesn't have to be f of x. It could be g of t. It could be s of r, where t and r would be your domain, your independent variable. G and s would be your dependent variable. So it can change from one thing to another. And it really depends on what the function's representing. You're very used to doing everything with x's and y's because you're just learning concepts in math. But in other classes other than math, and even in this class beginning, we're going to talk about the expressions that represent something. So we're not always going to use x and y. So when you have a function f of x, you want to determine y based on x, and you've been doing it with an equation. So this equation is a parabola. Let's say f of x is equal to 2x plus 7, and I want to find f of -2. Well, f of -2 would be 2 multiplied by -2 plus 7. So f of -2 would be equal to -4 plus 7, 3. That's how I find it algebraically. Graphically, you're going to look at this graph. So this function here is some function f of x. I typed it into Desmos and I just pasted it onto here. If I want to evaluate, say, f of negative 4, I'm going to go find where negative 4 is. So 1, 2, 3, 4. Here's negative 4 right here. I want to go to the function. I've got to go up to the function, and I'm going to find the y value. So this y value, there's 1, 2, 3, 4, 5, 6. This y value is 6. So f of negative 4 is equal to 6. Let's get a couple more colors. Let's say I wanted to find this one here. This is negative 2 right here. So if I want to find f of negative 2, I go to the negative 2, I go to the function, and then I find the y value that goes with that. This is negative 4. So f of negative 2 is equal to negative 4. Let's find another one. Well, this one I think is easy. Here's the point here you see is x equals 2. F of 2, I don't have to go up or down to get to the function at all. I'm right there at the function, so f of 2 is going to equal 0. And then the last one I have is, this is the x value. So this is 1, 2, 3. If I go up to the function and go across, 1, 2, 3, 4, 5, 6. I've got the 6, same as I did before. So f of 3 is equal to 6. So if I think of these all as points, this is the point negative 4, 6. This is the point negative 2, negative 4. This is the point 2, 0. And this is the point 3, 6. This was a function. All my x values are different. Negative 4, negative 2, 2, and 3. Notice my y values, I have some repeated there, but that's okay. As long as all my x values are different, it's a function. Okay, in graphing functions, there's a lot we're going to do in this section. All functions can be graphed by either knowing the general or the parent function, or by choosing values of the domain and calculating the corresponding values for the range. So later on, we're going to go through where we talk about the transformations of graph, and that's probably one of the easiest sections of Algebra 3, which is really nice to get to. But if I wanted to graph something, say I had f of x is equal to 2x plus 1. I can pick any values I want for x. And when I teach this, I said x, y, but I should say f of x. It's the same thing. I would pick negative 2, negative 1, 0, 1, 2. Just my standard numbers that I pick. I put a negative 2 in here for x. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. I'm going to find all these points first, and I'm going to plot them. Put a negative 1 in here. I get negative 2 times, or 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. Put a 0 in here, I get 1. I put a 1 in here, I get 3. I put a 2 in here, I get 5. So now I could plot these. This is my x-axis. This is my y-axis. I need to go negative 2, negative 3. Negative 1, negative 1. 0, 1, 1, 3, and 2, 5. And just because I picked these 5 points, it doesn't mean those stop there. This actually would keep going. So anything could be graphed. You don't need a graphing calculator, it just makes it easier. Okay, the other thing is this vertical line test. A vertical line test says if you run a relationship is a function if the vertical line only passes through the function once, no matter where the line is placed. So if I draw a graph here, let's just draw something like this. I could take a ruler. I could take this ruler, and when I pass it through, if I draw a vertical line through this, see, it only crosses it one time. No matter where I put that vertical line, it's only going to cross it one time. So this one is a function. If I draw another one, let's just do it this way. kind of the same shape, but now if I draw a vertical line through it, it's crossing it here, it's crossing it here, and it's crossing it here. So this is not a function. Now for most of you, the next part is going to be new. The idea of interval notation is just another way of using inequality notation, and it's used more often in upper level math classes. A bracket's going to indicate the point that is included, and a parentheses will indicate the point that's not included. And for me, it's easiest to show this on a number line. So if I had, say, x less than 3, but I want to make it greater than or equal to -2. If I plot that on a number line, there's my -2, here's my 3. It's including the -2, it's not including the 3, but I want everything in between there. Interval notation is going to say -2 to 3. It includes -2, it does not include 3. I'll give you several examples, and then we're going to use this throughout this course. If I want to say 4 is less than x, which is less than or equal to 7. Once again, I draw a number line, 4, 5, 6, 7. It's going to not include 4, so it's an open circle. It's going to include 7. So it looks like that. It's going to be everything in between. So that means it starts at 4, goes all the way to 7, and includes 7. So this is interval notation. It's actually easier, and if you were taught this before this class, most people find this a lot easier to work with. Now what happens if it's not between two numbers? What if it keeps going? Say I wanted to say x is greater than or equal to 0. Well, here's my 0. Greater than or equal to, so I want it to include 0, and I want it to keep going forever. Well, that means it starts at 0, and it goes to infinity. And infinity is always a parentheses. It will never stop, so it doesn't include that point. Similar to if I said x is less than, let's say 1. So there's 0, there's 1. Less than 1, so this is an open circle. It means everything left of 1. So that means it starts at negative infinity, and it goes all the way up to 1, but it does not include 1, so it's a parentheses. And that's interval notation. I think you'll find it easier to use. You'll get used to it once you practice it. And the last thing in this first section that we talk about the x and y intercepts. The x and y intercepts occur at specific points. So the x-intercept occurs when y equals 0. So if I look at this graph here, it doesn't even matter what this is. This is an x-intercept here, but the y value is 0. So I could call this the point A0. Here's another x-intercept. I could call this B0. And here's a y-intercept. I would call this 0C. So not a hard concept. I prefer when students give me x and y-intercepts to give it as a point. That way I know that the student understands what the x and y values really are.